Hey guys, and welcome back to this channel, or if it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, what we are doing is actually going back to the very basics of Ethernet switching, i.e. switching itself. And that is, as the title says, the thumbnail, what the actual trunk. We're actually going to build up to what is a trunk connection or interface. But before that, before we go through what is a trunk, what is its purposes, and in the lab itself, we're going to go through what is a LAN, what is a VLAN or virtual local area network, what are the differences, what is an access interface on a switch, and thus build up to what is the trunk interface itself. And of course, as always, this is all done on the Juniper Junos devices. And in the lab, what we're actually going to do is start off with what's known as a router on a stick model. It's a little bit of a legacy configuration, this, and you'll understand why. And from that, we'll then move on to how you can simplify that, how you can use more modern switches to actually get rid of that router on the stick model. At some point we still need routers, of course, but technology has progressed, chipsets, etc., and now these switches can do a lot of functionalities that a general router can actually do. So let's get on to the lab and let's get going. And here's the lab for this video. As you can see, it's not very big, it's not very complicated, but we don't need it to be just for training purposes. But we will just discuss what we actually have here, just so it starts to make a little bit of sense. Now, what we've got here is an EX switch. So if you don't know what EX is, it just stands for enterprise switch, but that's specifically a Juniper switch. And I should say it's a virtual EX or VEX switch, or VJunos as it's officially called, but that is the switch, and this is providing, as we know with switches, layer 2 functionality. Now that is all this switch is really doing here. As I said during the intro, a switch can perform the functions of a router, or some of those functions, not all of them, because they are different network devices completely. But that's why we've got another device up here, which is our VMX. I'm remembering the X the V this time. That is our virtual MX router. Now the reason why we've got this VMX here is because this is providing that layer 3 functionality. As I just said, this switch, the VEX switch, is only providing layer 2. So any hosts that want to communicate outside of their broadcast domain, and we'll come on to that, they have to go through a router or a routed interface, wherever and whatever that actually may be. And that's where the VMX actually comes into. There's a few tongue twisters there. Apart from that, all we then have are 3 different hosts. Now, 2 of these are in the same broadcast domain, and the other one is in a completely different broadcast domain, hence the need for this VMX router to provide that capability to span from one VLAN into another. So what we've got here is host 1 and host 2. Now host 1 and host 2 are in the same subnet. They are in that 192.168.10.0/24 subnet. And then we've got host 3 here, that is in a different broadcast domain. This is in 192.168.20.0, again, /24. And I didn't say it just then, but obviously you can see it. Host 1 and 2 are in VLAN 10, whereas host 3 is in VLAN 20. Now I've said the word there, VLANs, quite a few times. If you don't know what a VLAN is, here's a link that, to a video that I created a few weeks ago, which goes into what a VLAN actually is. We're going to cover and refresh ourselves on that just right now, but check out this video. There's more content in there. But before we get to what is a VLAN, let's first go through what is a LAN. So LAN stands for local area network, and as the name really implies, this is a local network. It is a network that's geographically local. That might be some tenants, some users on a floor in an office, or it might actually be the whole floor itself. It depends how you want to segregate or disperse that floor that in that building, etc. But it is a local network. That's basically it. And when we start talking about LAN switching, we are of course referring to these devices here, which are switches. Now switches, they will always function at layer 2. So if you don't know what these layers are, again, check out this link. It'll go through the OSI stack or the TCP/IP stack and the names of the different layers, etc. But coming back to this video, what the technology uses at layer 2 is something called frames. And what Ethernet uses at layer 2 are frames itself. I'll just go onto the Ethernet frame in just a few minutes time, but just so you know, there is always a source and always a destination. Even if we're talking about IP packets, IPv4 or IPv6, there's a source, there's a destination. When we're talking about UDP or TCP segments, there's always a source, there's always a destination. As a philosophical saying I've got, to know where you're going, you've got to know where you've come from. Bit philosophical, I know, but it's just how I remember that. But let's come back to what this switch actually does and the purpose of this local area network. And what I've just added on very quickly are these users. I'm a terrible artist, so I've not even tried to draw a laptop or some kind of server, whatever it may be. So let's just call these users, users 1, user 2, all the way up to user 7, and they're connected to ports 1, 2, 3, 4 respectively, all the way up to port 7. Let's just keep it simple. So these users, as I just might say, they might be your VoIP phones. It's a separate topic, but they might be your VoIP phones, they might be your laptops, they might be your iPads, which is what I'm using here to actually draw on. It's something that you are using to have a wired connection into that switch itself. Now, in a LAN, without going into VLANs, if there's no VLAN, everything is communicating within that same broadcast domain. Whilst that might sound easy in terms of configuring the switch to allow all these 7 different users to communicate to each other, and of course is, typically you don't really have to do anything anyway, there are some limitations to this kind of approach. Just for example, say we've got a new port here, so I'm just going to do this port here right on the end, and say port 8 comes in here. Now, user 8 I should say. So user 8, when it first connects to this switch, it's going to send out what's known as ARP requests, and there's going to be other packets flowing back and forth, DHCP, DNS, etc. But ARP is a protocol, it's a mechanism for user 8 to learn the MAC addresses of associated IP addresses within that same broadcast domain. So if it wants to know, what is the MAC address behind user 1, just for example, and it's going to then send that to that switch, and that switch will update its MAC address table as well as this ARP table to know that we've now got user 8 connected to port 8. But then if it doesn't know where user 1 is connected on that LAN, it's then going to send out of all ports, are you user 1, are you user 1, are you user 1, are you user 1, are you user 1. And that's what we mean by a broadcast domain. It's literally flooding all of those connected ports with that ARP request. If you don't know what ARPs are, check out this link. Here's a video just to briefly describe what ARPs are. But that's basically it. It's asking what is the MAC address behind this IP, and if that switch doesn't know where that MAC address actually is, or if there's another switch up here that's connected, it could also send it out all the way over there. That's what we call a trunk interface, coming on to that very soon. So a broadcast domain absolutely needs to be minimized, because the more users, the more ports you have connected within that same broadcast domain, that's increasing the scope of that flooding and learning. That's what Ethernet basically uses. That's what layer 2 uses to learn traditionally, without going into other protocols such as EVPN, to learn who's connected to where. But what's another problem with having all these users 1 to 8 now connected in the same LAN? Yes, we've gone into that broadcast flooding and learning, and there's a specific acronym that it will always make me laugh. I'm a bit of a child like that, called BUM: broadcast, unknown unicast, and multicast traffic. If all users are in that same broadcast domain and you have a broadcast frame or packet, or if you have an unknown unicast or multicast traffic, all users could potentially receive those same copies. So it's not really an efficient way. So we need to segment this. But additionally, what if user 1, 3, 5 and 7, going with the odds, are in a particular department? Let's just call it just VLAN 10. See where I'm going there? Because I got VLANs 10 here. Hey, there's logic to my insanity sometimes, but say they are in a specific department, i.e. VLAN 10. That could be sales, engineering, HR, legal, engineering, you know, we've all got an imagination, you see where I'm going. But say users 2, 4, 6 and 8 are in a different department, so they would go to VLAN 20, i.e. host 3 right here. The reason why you want to do that is because you want to keep those different departments' traffic absolutely separate from each other. You don't want users in VLAN 10 to be seen by users in VLAN 20. You don't want them to see each other's traffic, and also you want to minimize that scope of that broadcast storm of this bum traffic itself. And that's essentially what VLANs allow, is they allow to a certain degree security. Now I personally think of this as more as privacy, but you can assign a certain amount of privacy or security by using what's referred to as tag or tagged traffic. So what that saying means is if someone says, oh, these packets, these frames are tagged, they actually could be, need to obviously confirm, but they could be referring to actually this frame, these users, these hosts in a particular VLAN scope, i.e. a VLAN broadcast domain. And because, as I just said, users in one VLAN tag cannot see users in another VLAN tag, just default configuration, then you do have a certain element of security there. Additionally, what we can also have is priority. So in the actual VLAN header, which is altogether 4 bytes of overhead, in here is actually only 3 bits. Now each bit is obviously a 0 or a 1, so if you've got 2 options there. So if you do 3 bits to the power of 2, 2, 4, 8, you have 8 different options. So 0 is a number. A VLAN can have a priority of 0, which means it's really not important, it's really best effort traffic, whereas 7 is something like network control traffic, very important traffic basically. And what we can also do is identify via a VLAN identifier what that VLAN actually is. So we can identify that VLAN, i.e. VLAN 10, 20, 30, but we can also identify, is this a C VLAN or customer VLAN or end user VLAN? Is it a S VLAN? In some service providers they will call this the P VLAN because they're taking in those customer VLANs, they're adding their own tag on top of it, and thus they were referring to a P VLAN. And you can also have what's known as the E VLAN or enterprise VLAN, but I've never really seen that on any configuration. And this is the actual VLAN header itself. So altogether this makes up 4 bytes of overhead. So what we've got here is actually 2 bytes, which is identifying or allocated to the tag protocol identifier. Tag protocol identifier, i.e. what type of VLAN am I? Am I a C VLAN? Am I an S VLAN? Or am I an E VLAN? Now it's not as straightforward as that. They have hex values. So a C VLAN would typically be something like 0x8100 or maybe 0x8888. They have different hex values, but that is what the TPID is, actually identified. Am I a customer VLAN? Am I a service provider VLAN or P VLAN, or am I an enterprise VLAN? And then we've got 12 bits, just to make that a bit more clear there, we've got 12 bits to the identifier itself. As I said, we want to segregate, we want to keep away other departments' traffic from each other, and that's where the identifier comes in. So here we would say, well, if the switches were to actually be more specific, this is VLAN 10 or it's VLAN 20 or whatever it actually may be. The value here can be quite high. It can go all the way up to, because this is 12 bits, if you do 2 to the power of 12, you'll come out with something like 4096. That's actually not enough though. That's very scary. That's where other protocols such as VXLAN tunneling actually come into it, which is a really cool protocol. The priority or P bits, as they refer to, you've got 3 bits here. So I just said you can have really low, best effort, or really high priority at layer 2. And then we've only got 1 bit here to what's known as a CFI. I know it's spelled a little bit incorrectly there, but well, just from a letter point of view. But CFI, canonical field indicator, or depending on the type of VLAN itself, it could be a DEI, drop eligible indicator. So it does depend, but you only have 1 byte 1 bit, sorry, for this. But altogether, that is then 4 bytes of overhead. But where does this then sit in that Ethernet frame? And so I've just quickly drawn the Ethernet frame. We're not going to go through all these different headers, and I just realised I remembered a part that's not actually got, it's not technically a header, but it's essentially really important to the Ethernet frame. So we've got our interframe gap here. This is just basically a legal minimum separation of a certain amount of bytes between every Ethernet frame, because it's a bursty type of traffic. We've got our preamble, starter frame, our destination MAC, our source MAC. A type or length, there's actually 2 different types of Ethernet frames. You've got your Ethernet DICS or DEC Intel and Xerox Ethernet frame, and you've got the IEEE 802.3 frame. But depending on which one, the DICS Ethernet frame will use a type. The 802.3 frame uses a length value. That's why I've wrote the 2 here. We've got the payload itself. So in here somewhere will be IP, in there somewhere will be TCP or UDP, and then right at the end we've got frame check sequence, FCS, which is our basically error detection, not error correction, but error detection at layer 2. So where does that VLAN tag, that VLAN header actually sit? Well, it sits, and this is just a little bit of information that you may want to know. I'm like this, I like to know this kind of information, but it actually sits right in here. So it actually sits between the source MAC address and that type or length header, again depending on that type of Ethernet frame. And there's no real limit on the amount of VLAN tags you can have, but obviously every single time you add a VLAN tag, you are adding 4 bytes of actual overhead, and that will take not a huge amount of processing, but it will obviously consume a certain amount, and then you've got to have the memory on that switch for that actual VLAN tag itself. And speaking of switches, let's now actually go onto that Junos or VEX switch and start configuring all of this. So I'm on the Junos, the VEX switch, and if I just hit enter, you can see I've already gone into configure mode. So what I'm just going to do is just quickly show you how you can configure these access interfaces. I didn't actually mention this, but an access interface is when you're taking untagged traffic into the network. So if we look at it from host 1, host 2, host 3, it doesn't really matter. They're going to be sending in, whether it be ARP, ICMP, doesn't matter. They're going to be sending in frames and packets, which are essentially frames, which are not assigned to any VLAN from the host perspective. They're sending in Ethernet frames which have absolutely no VLAN tag actually within that Ethernet frame itself, i.e. it's completely untagged. What that access interface is doing is it's saying on the switch itself, right, I am configured to be an access interface. I'm going to allow in host 1 or host 2 or host 3, and I am going to tag it with this specific VLAN. That is essentially what an access interface does, is it allows access into this wired switch network, those access points, those servers, those branch devices, whatever it may be. It's all about access. So if I just do a quick show VLANs, you can see that there's nothing configured here for VLANs. So that is the first thing we obviously need to do. So you can see on the lab there is VLAN 10 and VLAN 20. VLAN 10 is assigned to host 1 or 2. VLAN 20 is only assigned to host 3. So let's just do set VLANs. Actually, I need to do set VLANs because I'm not in the VLAN branch. So I'm going to give this now a name. Set VLANs VLAN 10 with a VLAN ID of 10. And that's basically it. I can now do set VLANs v20 VLAN ID 20. If I do a quick commit check, obviously I know that's going to pass. And of course it does. However, what we also need to do is assign that Gigi 001, Gigi 002 and Gigi 003 to host 1, host 2, host 3 respectively, because we've got to allow them actual access into this network. So let's do set interface Gigi 000.0, which is Cisco's term for sub interface. We call them units, same thing. And this needs to be family Ethernet switching interface mode access. And now I want to say VLAN V. Actually, if I hit question mark, now it's just going to give me members. But now if I hit question mark, yeah, I haven't committed yet, but now I'm just going to say V10. Actually, I will commit to that configuration just so you could see the difference. And it's committed it. Now I'm going to run that same command again, but for the Gigi 002 interface to host 2. So it's do set interfaces Gigi 002, and I just realized I just made a mistake. Family Ethernet switching interface always do that, interface mode, access members, VLAN members. Now if I hit question mark, now we can see V10. Okay, so you didn't see him before because when I hit that question mark before I'd done the commit, because I hadn't committed that configuration. But now I need to do set interfaces gigi 003 to host 3, and this is going to be also an access interface. But first I need to say family Ethernet switching, so this is a layer 2 interface, and we need to have this in interface mode access with VLAN members, hit question mark, V20, auto populate it for me. Now I did make a mistake on the gigi 00 interface. Now this is actually the trunk interface going to that VMX router. I should have done this for the gigi 001. So I'm just going to do a quick delete interface gigi 000, and I'm now just going to do set interface, but now with the right interface. So gigi 001.0 family Ethernet switching, interface mode, access, VLAN, members, V10, hit commit, and that configuration is now done. So let's actually go onto those hosts now and see, can host 1 ping host 2? So let me just bring up host 1, drag it over here, and let's just do, I think the IP addresses are still going to be configured, but we'll see. So let's ping my own IP address of 192.168.10.1. Can I ping? Yes, I can. Can I ping host 2? Yes, I can. So we have basically just pinged from host 1 through host 2 through the gigi 001 interface and onto the gigi 002 interface. Now if I actually go back onto the VEX switch and run the command to see the MAC address table, so if I do run show Ethernet switching table, and now we can actually see we have learned the MAC address for VLAN 10 out of the gigi 001, gigi 002, but we can see host 1's MAC address here and host 2's MAC address here. So pretty cool stuff. But if I actually go back to host 1, can I ping from host 1 to host 3? So let's try that command. Let's do 192.168, well ping I should say, 192.168.20.3 for host 3 of course. And we cannot, you can see it's really struggling. It's just got, yeah, that host is unreachable. I cannot get to that. Do I actually have that IP address configured on host 3? So let's just go onto here now. I'm now on host 3 to see if host 3 can ping its own IP address. So ping 192.168.20.3, and it absolutely can. So what is the problem here? Well, let's go back onto the VEX switch and let's just do a little bit of troubleshooting. Let's do run show interfaces terse. I could just do match gigi 003, but I'm just going to run this just to be quick. It's going to give quite a big output, but I can see the port for gigi 003 is absolutely up. If I do run show VLANs, I can also see that we have got VLAN 20 with tag 20 assigned to the gigi 003 interface. So what is the problem here? The problem is absolutely this, is that host 1 and host 2 are both in this broadcast domain here. They're in this subnet of this network 192.168.10.0 with the subnet of /24, i.e. 255.255.255.0/24 basically. Whereas host 3 is in VLAN 20. It's all on its own, you know, bless its little cotton heart, but that is in the network of 192.168.20. Note the difference here, .0, but again a /24, i.e. 255.255.255.0. So they are in different broadcast domains at layer 3. They're never going to be able to reach each other unless host 3 was to move over into this configuration here. But again, you might not want to do that because you're increasing that broadcast domain. You want to minimize that as much as possible, whilst of course having that efficient communication within that own network. But we also still need to allow inter-VLAN routing. So inter-VLAN routing is quite literally as it sounds. Is we are allowing hosts in VLAN 10 to communicate to hosts in VLAN 20. Likewise and vice versa, we are allowing hosts in VLAN 20 to communicate to hosts in VLAN 10. Now you can apply firewall policies on the VEX switch and on VMX routers, and of course SRX firewall devices and QFX switches, etc., to limit this. So you can actually stop. We're not going to do it in this video, but we can stop host 1, just for example, communicating completely with host 3, but still allow host 2 to communicate to host 3. It's basically firewall policies, which can be at that level very straightforward, but obviously can get a lot more complex. But this is where we have inter-VLAN routing. But here's the problem. We have got our layer 3, as I said right at the beginning, all the way up here. Right here we are only providing layer 2. Now that is where the connection between this VMX router and this VEX switch actually come into it. On this GIGI00 interface on both ends, this is going to be trunk. What the actual trunk, as that thumbnail said. It's a bit of a bad spelling there. It almost looks like trunk. In fact, I'm going to have to change that. It's going to bug me. And there we go. That looks better, doesn't it? It now says trunk instead of troke. I don't actually think that's a word. But what a trunk basically allows is it allows for, if this is that connection between the router, the switch here, and the router over here, what it would do is it would allow within here VLAN 10, VLAN 20, and any other VLANs which are configured on that switch. Now to also allow untagged traffic to pass through that trunk is where something is called, and it can sometimes be confusing, but a native VLAN. So all devices will have a native VLAN. By default it's pretty much always set to 1. Security recommendation is always to change that, but that native VLAN is basically allowing any untagged traffic to pass over that trunk itself, and this will have a VLAN identifier to it as well. So again, we're allowing separation, security, priority, etc. So native VLAN. But coming back to this, we're not going to configure native VLANs, but coming back to this is we are going to configure on the trunk here VLANs 10, VLANs 20. But we also then have to configure on this device up here, the VMX router, those layer 3 integrated routing and bridged interfaces themselves for those VLANs, and that will actually allow that inter-VLAN routing. Why? Because we always assign statically, I've done it statically, but if it was DHCP it would be done dynamically, there will always be a gateway IP address, which is right here. So we can actually see that gateway for VLAN 10 is 192.168.10.254/24. And likewise for VLAN 20 it's 192.168.20.254/24. So when these devices want to, and I'll just clean up the screen a bit. So when host 1 wanted to ping, I do an ICMP to host 3. Originally it went to here, but then this switch was like, well, I'm not configured for this. I'm not configured to allow inter-VLAN routing. But now, as we'll do in just a minute, it can then send those frames up to here, and that's going to hit that gateway, because we're in VLAN 10 here. It's going to hit the VLAN 10 gateway, and VLAN 10 is going to say, well, the VMX router is basically going to know, because it's got its routing table, you want to go to 192.168.20.3. that is your destination. I have that in my routing table, so I'm going to route you from VLAN 10 into VLAN 20, and boom, back down it goes all the way to here, and then it will send the response back. But that is what a trunk basically does, is it allows you to trunk together those tagged frames and untagged frames via the native VLAN between different devices. Now that is point to point, and if you are doing native VLAN troubleshooting tip, that native VLAN has to match per end. You can't have native VLAN 10 on one end and native VLAN 100 on the other end. They do have to match. Traffic will still pass, but it's not going to be great, let's just put it that way. But that is what a trunk does, and that is why we have these gateways for those VLANs to allow that inter-VLAN routing. So let's now go on that VMX router and configure this. So I'm on the VMX router, and the configuration to do this is very straightforward. This can be a lot more complex because the MX routers are designed for enterprise networks and service provider cores, so this can get very complex. But for what we want to do here, going to keep it very straightforward, trust me on that one. So how do we actually configure that GigE00 interface to be a trunk? Well, it's not something we actually have to define. We don't have an interface mode trunk. Well, there is, but again, we don't need to do it here in this particular scenario. So now I'm just going to say set interfaces GigE 000.0. And what I now want to say is I want this to be, actually I need to do just 0, so I'm going to get rid of the sub interface. And I want to say I want this to be VLAN tagging. So I've immediately said this port, GigE000, it is going to be doing VLAN tagging. So I now need to define, and now I'm just going to add that unit back into it. I want to say I want this to be part of VLAN 10, VLAN 20. So now I'm just going to say VLAN ID 10, but I also need to give that gateway address. So here I'm now going to say family INET address 192.168.10.254/24. That's it. I've basically just configured GigE000 to participate in VLAN tagging. And now I'm just going to do the same on the set GigE000, but now I'm actually going to do the right unit. I'm going to say VLAN ID 20. I'm going to do family INET because this is our layer 3 gateway with the address of 192.168.20.254/24. So now if I just do show interfaces, just a little mistake here. I wrote this as unit 0. Where it's actually using VLAN 10. It would still work, but you know, it's just good practice to have the unit pointing to the same VLAN. So I'm just going to change that. Here's a quick command for you. So what I'm going to do is I'm going to quickly just go into edit interfaces GigE000. Let's do show so I can see the information. And what I want to do is rename unit 0 to unit 10. And now if I just do a quick show again, well, hey, look at that. I think that's such a great command. We've immediately changed from, if I just scroll back up, unit 0 here for VLAN 10 to unit 10 here for VLAN 10, just using that one command. Very, very nice instead of deleting it and adding it back in. So let's actually do a commit on this configuration. So that's committed, that's fine, that's passed. There is, of course, another end to this trunk. We've configured the trunk on the MX router, but of course we need to do this on that switch itself. So I'm just going to go back onto the Junos, the VEX switch, and let's just quickly do set interfaces set GigE000.0 family Ethernet switching interface mode, hit question mark, and now you can see we can set it as trunk. Now there are some additional commands after this, so you could do inter-vlan, you can do some kind of policing on this trunk interface itself, so you need some firewall policy to define those policing attributes. Whole different topic, I know, but now I just want to say VLAN question mark members question mark. Now what do I want to add in here? Do I only want VLAN 10? Do I want VLAN 10 and VLAN 20? So you then have to open up the set of values here separated by a comma, I believe. But now I'm just going to say all. So I want all VLANs, including that native VLAN, to be part of this trunk interface. So let's do commit. And now if I just do quit, show VLANs, and we can now see that the trunk, the GigE00 interface, is part of the default VLAN, which is just by default also part of the native VLAN. I've not changed it. VLAN 10 is part of GigE000, and VLAN 20 is part of GigE000. So this now should absolutely work. So I'm just going to get rid of these displays, and let's get rid of that lovely writing of mine. So let's now go back to host 1. Now can I ping my gateway? Ping 192.168.10.254. This should work, and we can now ping all the way from host 1 up to the gateway, which is on that MX router. But can we now ping that IP address of host 3, which is 192.168.20.3? And there we go, we can. So this configuration is working, looks good, perfect. But there is one little slight problem here. It's not so much of a problem, it's a bit more of a design flaw, I should say. because we are sending traffic all the way up here, and then it's passing through the gateway and coming back, and then going all the way back up there for the response and coming back, etc. That's not really a great way of communication, is it? Just for traffic to go all the way up to come all the way back down again. And this was actually pretty common with what was called a router on a stick actual model. Now this is before switches could actually do layer 3 functionality, and what we're going to do now is we're actually going to completely remove this MX router or this VMX router from this configuration. And what we're going to do is on the VEX switch itself is we're going to enable and configure that layer 3 functionality on that Junos switch itself to do that inter-VLAN routing there. And that is of huge benefit, because then all traffic from host 1 to host 3 can stay local here. It doesn't have to go all the way up to only come all the way back down again. It's all staying local just here. So that's obviously a benefit, and it's a bit more of an efficient design, a bit more of an efficient architecture itself. But let's move on to that VEX switch and actually configure that. So what I'm going to do is I'm just going to disable the link between the MX router and the VEX switch, so you can see I don't need to do it on both ends. I didn't know that. You learn something new every day, but you can just see the little red dots here, so it's completely suspended. And just to prove that, if I just do run show if I do show interface terse, look for the gigi00, you could see it's admined up, but the link itself is down because I've suspended it. That's fine. That's exactly what we needed to see. But let's go into configure mode, and let's just make sure those VLANs are still there. So let's do. So it's not do show configuration. You get a whole big output, but here just right at the bottom you can see those VLANs are still there. What is missing in there though is that layer 3 interface itself, i.e. that IRB, the integrated routing and bridged interface. So I need to go into VLANs, and here I'm just going to do show. Now I can say set VLAN 10. If I hit question mark, you can actually see here it now says layer 3 interface. So that is that's gateway basically. And if I just move it, we're going to move the gateway from the MX routers here down to the VEX switch. So I'm going to say set layer 3 interface. Now we don't define the IP address just yet, because this is a VLAN. We need to point that VLAN to a layer 3 interface. So we need to define that interface itself. So that is the IRB, again, integrated routing and bridged or bridging interface. So for VLAN 10, that's IRB 10, and for VLAN 20, it will be IRB 20 itself. So I ran a quick commit check and it passed, and you can now see the configuration has been added to those VLANs for those layer 3 interfaces. But if I do top, and let's move into edit interfaces to do a quick show, you can see we don't actually have any IRB interfaces. We've got our gigi000, which I can actually completely delete right now, but I won't do that. We've got our gigi001 is accessed with VLAN 10, for the same for gigi002. Our gigi003 is here, but we don't have the IRB interface. So now I can actually say set IRB 10 unit, family inet. There's no unit in the IRB, so I always forget that. And I want to give this the gateway address. So for IRB 10, that is 192.168.10.254/24. Let's do the same for IRB 20, family inet 192.168.20.254/24. Let's do a quick commit check, and that has succeeded. I will now push that configuration and I will quit into the operational mode. And now if I actually just do show VLANs, we can see all the information that we can before. But if I actually do a show interfaces, and let's just do gigi 0, actually I wanted to do IRB 10, I was going down the wrong track there, but you can now see all the information for IRB 10. So I can check if I got the right IP address, 192.168.10, it would be a .0 there. But that's just the destination. Here's the local IP address, so 192.168.10.254. Everything is looking good. But let's now test that. Can host 1 ping host 3? Or actually, can it actually ping the gateway before we go any further? So let's do ping 192.168.10.254, and we absolutely can. So now VLAN 10, sorry, host one in VLAN 10 can ping that default gateway, VLAN 10 gateway, on that VEX switch now. It's no longer up on the VMX router. Can I still ping from host 1 to host 3? And you absolutely can. Again, without any firewall policies in place, it's just automatically going to allow that inter-VLAN communication. And so that's the end of this video, everyone. I hope you found that useful. We've gone through a lot of information in terms of what is a LAN, what is a VLAN, what are the differences between the two, why do we need VLANs, why they're of benefit, and on the Juniper Junos devices, how to configure a VLAN on that EX switch, how to assign that to an access interface. What is an access interface? What is a trunk? What are the benefits of the trunk? And why do we need to do inter-VLAN routing? And we also covered what is that route on a stick model, as we saw, as we pretty much worked off. And then how you can make it a bit more efficient by actually doing that inter-VLAN routing on that same switch itself. So if you like this video, please hit like, please subscribe. Please give me any comments. I love hearing from you guys. There's more content as always coming. Other than that, stay tuned. Thanks for watching and goodbye.